Good morning, all of you. In this session, I'm going to explain about these two problems. In this problem, I will explain how to shifting of a single force into force and couple for this problem. For this problem, I will explain how to determine resultant, magnitude of a resultant and the direction of a resultant. I will explain about these two problems in this session. This is the first problem. A system of parallel forces are acting on a rigid bar as shown in figure. Reduce this system of forces into a single force. A single force and a couple at point A. A single force and a couple at point D. Okay, this is the question. And the given diagram is like this. A force of 100 newtons acting at a point A, and force F2 equals 16 newtons force acting at a distance of 1 meter from point A, and another force F3 equals 15 newtons acting at point C at a distance of 2.5 meters from point A, and another force F4 equal to 18 newtons acting at point D at a distance of 4 meters from point A. Okay, this is the given force system. Okay, here you can observe these are the parallel forces acting on the rigid bar. Okay, here you have to convert these four forces into single force, that is resultant. That is the A bit. In second bit, you have to shift that single force at point A. Okay, you have to shift the resultant force into single force and couple at point A is the case B. And the last bit is you have to shift resultant force at point D. Okay, so these are the important sign conversions. For right side direction, positive sign; for left side direction, negative sign; for upward action, positive sign; for downward action, negative sign. Okay, these are the important conversions. First, you have to find out a magnitude and a direction of the resultant. You can observe from the given diagram, there are no horizontal forces. Okay, there is no horizontal force. You can observe here, these all are vertical forces. That's why sum of all horizontal forces equal to 0. Okay, and the sum of all vertical forces equal to, you have to consider positive sign for upward action, negative sign for downward action. So this value is minus 100, this one is plus 60, this one is plus 50, this one is minus 80. Okay, so minus 100 plus 60 plus 50 minus 80. Okay, sum of all vertical forces equal to minus 70 newtons. Okay, now you have to find out the value of magnitude of a resultant. Already we know the formula for resultant. Resultant equals square root of horizontal forces square plus vertical forces square. So square root of 0 square plus minus 70 square equal to 70 newtons. This is the magnitude of a resultant. And also this is a single force. Okay, this is a equivalent force of these four forces. Okay, now already we know the formula for direction of the resultant. The direction of the resultant theta x equal to tan inverse of vertical forces divided by horizontal forces. Okay, tan inverse of minus 70 by 0. Anything by 0 is equal to infinity. So tan 90 degrees equal to infinity. So the value of theta x equal to 90 degrees. That means the resultant makes an angle theta with respect to x-axis. Okay, theta equal 90 degrees. That means the the resultant force acting towards down, vertically downward. Okay. Yeah. Here, let resultant force acting at a point here. I consider this point as E. Okay. Yeah, I don't know the position of resultant. Okay. Let x is the distance. Okay. This resultant force acting at a distance x from point A. Okay. So here the value of Fy equal to minus 70. That's why you have to consider negative sign for downward direction, and the value of resultant equals 70 newtons. Okay. So from this diagram, you have to find out the value of x, that is the position of resultant. That is very important for this problem. So for determining the position of the resultant, first you have to find out the moments of all forces. Already we know the formula for moments. Okay, you have to consider these signs for moments. For clockwise movement, you have to consider negative sign. For anti-clockwise movement, you have to consider positive sign. These are the important sign conversions for moments. Already we know the formula for moment. Moment of force equal to force into perpendicular distance between the force and point. Okay. So you have to find out all these forces. Moment of force F1 equal to force into distance. Here this force acting at a point A. That means here I want to find out the moment of force about point A. Okay. So this force lies on point A. So there is no perpendicular distance. So the distance is 0. Okay. And the moment of force F2 about point A equal to 1 meter is the perpendicular distance, and the force is 60 newtons. So 60 into 1 meter is the moment of force F2. Here, with respect to point A, this force F2 forms a anti-clockwise couple. Okay, anti-clockwise couple. So you have to consider positive sign for anti-clockwise. So plus 60 into 1 equal to 60 Newton meter. In similar way, F3, the moment of force F3 equal to force 50 into distance from point A, 2.5 meters from point A. Again, this force 50 Newton force with respect to A forms a clockwise anti-clockwise couple, anti-clockwise. Okay, so positive side for anti-clockwise 50 into distance 2.5 meters. The moment of force F4. This one is F4. The moment of force F4 equal to 80 newtons equal about point A. The distance between force F4 and point A is 4 meters. So 4 into 80. 4 into 80 is the moment of force. And this force forms a clockwise couple with respect to point A. This force forms a clockwise couple, that is minus. Okay, minus 4 into 80 equal to minus 320 Newton meter. In similar way, the moment of force for resultant, the distance between resultant and point A is x. Okay, the value is 70 into x for moment of resultant. This resultant force forms a clockwise couple. That means negative sign. Minus 70 into x is the force. Okay. Here, by using these 5 forces, you have to find out the value of x. That is the position of resultant from point A. Already we know the principle of moments or Bernoulli's theorem. From the principle of moments, the moment of resultant equal to sum of all moments. So Here r into x is the minus 70 into x. The value of r into x equal to minus 70 into x. And f1 d1 plus or minus f2 d2 plus or minus f3 d3 values are 0 plus 60 plus 125 minus 320. These are the individual moments. Okay. Now from this equation we got the value of x equal to 1.92 meters. That means this resultant this resultant force lies between point B and C. You can observe the distance from A to B is 1 meter and B to C is A to C is 2.5. Point A to C is 2.5. So the position of resultant is 1.92 meters. That means this resultant force lies between B and C. Okay, this resultant force lies between B and C. Okay, here this is the given diagram. So here I converted this diagram into a resultant single force diagram. Okay, this is the case one. That is a single force diagram. Okay, I converted these four forces into a single force. Okay, this single force is equal to the magnitude of a resultant. Okay, this resultant is equivalent to these four forces. Here you can observe x equal to 1.92. Okay, hence the given system of forces equivalent to a single force 70 newtons acting vertically downward at point E at a distance of 1.92 meters from point A. Okay, as shown here. This is a single force diagram. Now the second bit is you have to convert a single force into a force and couple at point A. Okay, you have to shift this single force to a force and a couple at point A. Okay, so for shifting the force, the resultant force are acting at point E as shown here. Okay, it can be replaced. This single force can be replaced by an equal force applied at point A by adding two equal and opposite forces at point A in the same direction. Okay, together with the couple as shown here. Here you can observe this is the single force diagram. Now you have to shift this single force from point E to point A. Okay, so you have to add two equal and opposite for single forces at point A. Okay, by adding the two equal and opposite forces, there is no change in the force system. Okay, there is no change in force system. Okay, because this is a minus 70, this is a positive 70 newtons. So there is no change. So from already we know the couple forces. This one here by acting two equal and opposite forces forms a couple. So this one is 70 newtons downward direction. This one is 70 newtons upward direction. Okay, the distance between these two forces is x. Okay, these two forces form a couple at point A, like this. Okay, so these two forces form a clockwise couple at point A, and the value of this couple is force into distance between two forces. That is force 70 into distance between two forces equal to 1.92. This is the magnitude of a couple. 70 into 1.92 Newton meter is the couple. Okay, so here I shifted this resultant force from point E to point A, like this. Okay, this is a case B. Just I added two equal and opposite forces at A. Okay, these two equal and opposite forces form a couple at point A. Okay, and the third bit is a single force and a couple at point D. So in this case, you have to shift this single force from point E to point D. Okay, by adding two equal and opposite forces. By adding two equal and opposite forces at point D, you can shift this force from E to D. Okay, here I added two equal and opposite forces. This one is minus 70, this one is plus 70. Okay, there is no change in the force system. Now, these two are the equal and opposite forces, 70 newtons, 70 newtons. The distance between these two forces is 2.08 meters. Here, the distance between A to D is 4 meters and A to E is 1.92. Subtract this 1.92 value from 4 meters. Okay, 2.08 is the distance between ED. Okay, so these two forces, the 70 newtons and 70 newtons, these two are the equal and opposite forces, form a couple, that is anti-clockwise couple at point D. Okay, here you can observe this is the anti-clockwise couple. This is 70 newton force and this 70 newton force. These two forces form a couple at point D. Okay, the value of this couple is force into distance between two forces. The force is 70 into the distance between two forces is 2.08. Okay, this is the magnitude of the couple. Okay, here you can observe I shifted this single force from point E to point D. Okay, by adding two equal and opposite forces at point D. Okay, this is the final answer for this question. Now coming to the another example, a system of forces are acting on a rigid circular plate ABCD as shown in figure. Determine the magnitude and direction of the resultant. Okay, here this is a circular plate A, B, C, D. Okay, a system of forces are acting on a rigid circular plate ABCD as shown in figure. Okay, determine the magnitude and direction of the resultant. Here, a horizontal force 20 newtons acting at a point B. This is a horizontal force. And another horizontal force 60 newtons force acting at point D. This one also horizontal. Okay, and a inclined force 40 newtons makes an angle 30 degrees with respect to x-axis acting at a point C. And another force 18 newtons. This one is vertical force acting at a point A. Okay, these are the four forces. Okay, you have to convert these four forces into a single force, that is the resultant. Okay, now first you have to draw this 60 newtons force as it is. Okay, and now I am considering this 20 newton force as it is because there is no need to convert horizontal and vertical forces. Okay, after that you have to consider this 80 newton force vertical force as it is. Okay, now this one is a vertical, this one is a inclined force. You have to convert this inclined force into horizontal and vertical forces. Okay, we need to convert inclined forces into horizontal and vertical forces for solving the resultant. Okay, you can observe this 40 newtons force lies in first quadrant. Yeah, this is the x-axis, this is y-axis. Okay, you can observe this is y-axis, this is x-axis. So this 40 newtons of force makes an angle 30 degrees with respect to x-axis. So this 40 newtons force lies in first quadrant. So you have to convert this 40 newtons of force into x component and y component like this. Okay, so this is 40 cos 30. For adjacent sides, you have to consider cos theta. For opposite sides, you have to consider sin theta. So this is a 40 cos 30 degrees, cos 30 degrees, and this one is 40 sin 30 degrees. Okay, so now I am drawing these two forces at point C. Okay, so 40 cos 30, 40 sin 30. I converted this inclined force into horizontal and vertical forces. Okay, now you have to add all horizontal forces and vertical forces. These are the important sign conversions. For right side direction, positive sign; for left side direction, negative sign; for upward action, positive sign; for downward action, negative sign. Okay, sum of all horizontal forces. Here from this diagram, first you have to identify horizontal forces. This one 20 Newton force is the left side horizontal force. This 60 Newton force, right side horizontal force, and this 40 cos 30 also a horizontal force. Okay, for right side direction positive sign, for left side direction negative sign. So 60 newtons right side, so plus 60, and this one is left side direction, so minus 20. This one is right side direction, so plus 40 cos 30. So 60 plus minus 20 plus 40 cos 30. So this is the answer for horizontal force. Sum of all horizontal forces equal to plus 74.64 newtons. Okay. Now you have to consider vertical forces. This one is vertical force 40 sin 30. This one also vertical force 80 newtons. Downward, for downward direction minus sign, for upward direction plus sign. Sum of all vertical forces equal to Fy. Okay, so plus 40 sin 30 minus 80. These two are the vertical forces. So for upward action positive sign, for downward action negative sign. Sum of all vertical forces equal to minus 60. Okay. Now you have to convert these two forces into a single force, that is resultant. Already we know the formula for resultant. The magnitude of resultant, the magnitude of resultant, capital R equal to square root of horizontal forces square plus vertical forces square. So here already we know the value of Fx equal to 74.64 and Fy equal to minus 60. So square root of 74.64 whole square plus minus 60 whole square equal to 95.77 newtons. Okay, this is the magnitude of a resultant. 95.77 newtons is the magnitude of a resultant. Okay, thereafter you have to find out the direction of the resultant. Already we know the formula for direction of a resultant, that is theta x. Theta x is the direction of a resultant. Okay, the resultant makes an angle theta with respect to x-axis. With respect to x-axis. So theta x equal to tan inverse of Fy by Fx. Tan inverse of Fy by Fx is the formula for direction. So Fy equal to minus 60 sorry friends, this is minus 60, this one is minus 60, and this one is plus 74, plus 74.64. Okay, Fy equal to minus 60 and Fx equal to 74.64. So the angle theta x is minus 38.79 degrees. Okay, the resultant makes an angle 38.79 degrees with respect to x-axis in clockwise direction. Minus sign indicates clockwise direction, positive sign indicates anti-clockwise direction. So I will show the position of resultant. This is the fx. This is here you can observe fx means x component, that is x-axis. X component lies on x-axis, and fy means y component. Y component lies on y-axis. So I am drawing this y component in downward direction. For negative sign, you have to draw downward direction. Okay, Fy equal to minus 60. So negative sign indicates downward direction. This is a y component, that means y axis. Okay, and this one Fx is x axis, x component. The value is positive. So for a positive sign, you have to consider right side direction, right side horizontal x axis. Okay, this is positive x axis, this is negative x axis. So the resultant lies in fourth quadrant. So this is the position of resultant. This is the magnitude of the resultant, 95.77 newtons. Here the angle between resultant and x-axis is theta x. Theta x is the direction of resultant with respect to x-axis. So this is x-axis, this is y-axis. So theta x is the direction of the resultant with respect to x-axis. Theta x equal to 38.79 degrees. Okay, this is the position of resultant with respect to x-axis. Okay, this is the final answer for this problem. Okay. So you can observe. So this is the given question. Okay. Okay. Here you can observe. This is the given question. I converted this inclined force into horizontal and vertical forces. Okay. Then after you have to add all horizontal forces for determining the sum of all horizontal forces, summation f x. Okay, for determining the value of fy, you have to add all vertical forces. Okay, then after you have to determine the magnitude of the resultant and direction of the resultant. Okay. And this is the first problem. So it is very important for exam point of view. Okay, please all of you remember. Here, this is the single force. Okay, single force or resultant force. Okay, this is a couple. Okay, okay. In next class, I will explain about supports and support reactions. Okay, the topic also very important for determining the unknown forces. Okay.